So hello everyone, my name is Resuello Mark JCV from NS1A3. So for today, I'm going to discuss and solve the magnetic deviation through heading and through bearing. So let's have the scenario here. While steering to 135 degrees PSC along the Raccoon Strait, the bluff point light bore starboard quarter beam at about 20 hours. So determining the ship through heading and through bearing of the light observed. Use the given specimen of the deviation table for determining the deviation to apply the magnetic variation for the locality is 2 degrees west. So here we have the deviation table. So we are now going to find the 235 degrees. So there are no 235 degrees, so we are going to copy the compass heading, which is 225 and 240 together with their deviations 8 degrees east and 12 degrees east. So solving for the magnetic deviation for heading 235 degrees PSC by linear interpolation. So like I said earlier, we are going to list the compass heading 225 degrees, 240 degrees, and in between of them is 235 degrees. And together with their deviation 8 degrees east, X is for the deviation of 235 and 12 is the deviation of 240 degrees. So first is we need to find the difference between 225 degrees and 235 degrees. So the difference of them is 10 degrees. So next is we need to find the difference between 225 degrees and 240 degrees. So the difference of them is 15 degrees. So next is the same step in deviation. So 8 degrees and difference between X is we need to put X. And then next, the difference between 8 and 12 degrees. So the answer is 4. So after we get the differences, we are now listing the answer, which is 10, 15, and the deviation is X and 4. So now we are performing the cross multiplication. So 15 times X is equal to 15X. And then next is 10 multiplied by 4 is 40. So after we get the answer, we need to transpose the 15X to the 15 to the right side. So we are now having a X equals to 40 divided by 15. So now after we transpose it, we are now calculating 40 divided by 15. So the answer will be 2.67. So now we have X is equal to 2.67. So we are not done yet. So because the deviation is increasing, we are now going to add the 8 degrees to the 2.67. So plus 8 degrees. So the answer will be X is equal to 10.68 or 10.7 degrees east. So now we have the compass heading . To 35 degrees and deviation of 10.7 degrees east. So next thing is we need to do is to solve for the true heading. So we are now performing the correcting the compass. So now we are going to write the compass heading, which is 235 degrees. And the deviation of 10.7 degrees east. So due to the name of the deviation is east, we are now going to add them. So the answer will be 245.7 which is now the magnetic bearing. So next is we need to write the variation, which is written to the problem, which is 2 degrees west. And now we're going to minus the 245.7 and the 2 degrees west, because the name of the variation is west. That's why we need to minus it. So the answer or the true heading will be 243.7 degrees. So now we are solving for the true bearing. So first is to plot the heading for our vessel, which is the 235 degrees. And then to get the bearing, the true bearing is, which is the lightboard starboard quarter beam, that is equal to 135 degrees. So to get the true bearing is, first we need to add the heading 235 degrees to 135 degrees, which is the starboard quarter beam. So we have the answer of 370 degrees. So due to that 370 is higher than 360, the whole compass is, we need to subtract the 360, so the true bearing is 10 degrees. So to solve for our compass bearing, we are going to use the uncorrecting the compass. So let's start with the bottom to the true bearing up to the compass bearing. So now we have that the value of the true bearing, which is the 10 degrees or the 10 degrees. And then next, the given value of the variation, which is the 2 degrees west. So uncorrecting the compass, we need to add 10 degrees to 2 degrees west, because the name is west, which is we need to add. So the answer will be 0, 1, 2 or 12 degrees. And then write the deviation that we solved earlier, which is the 10.7 degrees east. So the name is east, that's why we need to subtract it now. So now we have the 0.3 degrees, which is the compass bearing. So that's it. This is the answer of the compass bearing. So that's all for today. Again, I'm Resuello Mark Jesse from NS1A3. Thank you for watching.